Alright, so I'm going to be going over the cooldowns with you guys from lessons 1 through 8. Okay, so this is what you guys were supposed to do on Monday and Tuesday when we were asynchronous. So I'm just going to go over them here. So on cooldown from lesson 1, it says on the same axis draw a line for a third turtle that is going half as fast as the turtle described in line G. So I'm looking at this line, and I need to create a line that represents a turtle that goes half as fast, okay? So the first thing I'm going to do is see how far line G has gone after 1 second. So I'm going to look, my y-axis represents the seconds. So after 1 second, G has gone 2 centimeters, because that's where it matches up. So if my turtle is going half as fast, that means after 1 second, he needs to have traveled half that distance. So half of 2 would be 1. So, and they all start at the beginning. So that's where my new point is. So now I'm going to look at 2 seconds. At 2 seconds, my turtle G has gone 4 centimeters. So at 2 seconds, I need to have traveled half of 4. Half of 4 is 2. So at 2 seconds, my turtle has gone 2 centimeters. And as you can see here, I have a little pattern. I go up 1 and over 1, up 1, over 1. So I'm going to continue that along the way. And we can just double check our work, because at 5 seconds, turtle G has gone 10. Half of 10 is 5. And that is where my point matches up. So here is my line. There we go. Alright, now it says explain how your line shows that the turtle is going half as fast. So we can say at each second, so at each second on here, I'm going to say my turtle has traveled half the distance as line G, or you could say turtle G, I don't know. But at each second, when I look at where the G turtle is, mine has always traveled half. So there's that. Oh, shoot. Alright, so for this one, we have a bunch of relationships here. Sorry, the lines are not very good. It didn't print well. It's not good for you guys either, so I apologize. But it says, which one is different than the others? Well, there's no information labeled on the axes, so let's just find the slope or the k value and try and create an equation for each of the lines. So once again, our k value is our y over x. So let's look here at this point. My x value is 0.8 and my y value is 4. So I'm going to take 4 over 0.8, plug that into your calculator, and you get 5. So my equation for this line would be y equals 5x. Right, let's do b here. So let's find my x value. So my x value is 10. My y value is right in the middle there. So let's go with 55. So I need to do my y over x, which is 55 over 10. Plug that into my calculator, and I get 5.5. So my equation for this line is 5.5x. So those two are different. So one of these is the odd duck out, okay? So let's go ahead and find the others. This one lines up at let's go with 4, because it looks like it's counting by 2s. This just doesn't look like a 4. Maybe it is. There. Okay, so it's a 4. And then this would be 20. So I'm going to take my y, which is 20, over 4, which is my x. So 20 divided by 4, I get 5. So my y equals 5x. Alright, so let's go ahead and just do this one for fun. So this one lands at, this would be 10, and right here would be 50. So 50 over 10 gives me 5. So if I look at all my equations for my lines, B is the only different one. Alright, on to the next. So of course the graph didn't print here, so sorry about that. So here we go. It says we need to sketch a graph that shows the relationship between honey and salt. So we don't even have to pay attention to that, okay? So let's go ahead and do this. So we can plot this point and then we can plot another, okay? Because ultimately we need to figure out how much honey is needed for 70 grams of salt, okay? So first off, our graph doesn't tell us that we start off with any kind of amount. So we know we're going to be starting at the origin. I'm going to go ahead and mark up my graph. Alright, so here we go. I just went by 10s on each axis. Now I can go ahead and plot this point here. So at 10 on my x-axis, my y would be 14. So right in the middle there. So that's where 1 point is. Now I need to figure out how much honey is needed for 70 grams of salt. So what I'm going to do is I need to make an equation for this line. And so in order to do that, I need to have my y over my x, which would be 14 over 10, which equals 7 over 5. And that's what my equation for this line would be. Now, how much honey is needed for 70 grams of salt? Okay, so x represents salt, so I'm going to plug in 70 here for x, and if I do that, I get y equals 7 over 5 times 70. If you plug that into your calculator, so 7 divided by 5 times 70 equals 98. So when my x is 70, my y is 98. There we go. And there's our line. So that one's not too bad there. Okay, we have two different salt mixtures here. So mixture B has this equation. So x represents salt and y represents water, okay, for this mixture. So we're mixing salt and water. And so that's that equation, and then the other mixture is represented by this table. Since we have an equation over here, let's go ahead and create an equation for this one. So we're going to label our x and y, and in order to create an equation, we have to find our k value, which is our y over x. So 5 over 4. I cannot simplify that, so my equation for this one would be 5 over 4x, or if you want to write that as a decimal, we would get 1.25. So, or y equals 1.25x. Okay? Alright, now it says if you used 10 cups of water, which mixture would use more salt? Okay, so y represents the water, so we're going to plug in 10 for y in both of our equations here. So let's do A. So 10 equals 1.25x, because water is represented by y, and we want to figure out how much salt when we have 10 cups of water. So x is connected through multiplication, so to undo that, you divide by 1.25, and our amount of salt is 10 divided by 1.25. I get 8. So we would have 8 teaspoons of salt. I think that's a lot of salt, but I don't know. Alright, now let's look at mixture B. We're going to do the same thing. So 10 equals 2.5x. Divide by 2.5. And x equals 4. Okay, so it says, which one would use more salt? Well, for 10 cups, we used 8 teaspoons for mixture A. So it would be mixture A. Because it uses 8 teaspoons of salt when mixture B uses 4. So that is how we know. Now it says which mixture would taste saltier. So we can use this example here. So technically we don't know which one tastes saltier, but if we look at these two and we have 10 cups of water and this one has more salt in it, sorry, it started to rain, wouldn't the one with more salt taste saltier? That's what I think. So mixture A contains more salt. Alright, so here is a graph that represents some stacked cups. So it says how much does each cup after the first add to the height. Okay, so there's two different ways we could do this. So if we think back to lesson 5, we were able to find that K value, and that K value then helped us figure out at what rate we were increasing by. Okay, so there's two ways we can do this. You could use a table, and we can plug in our values here, so our X and Y values. And so if my X is 3, my Y is then 5.5. My X is 8, my Y is 8. So in order to find my K value, I need to figure out at what rate I'm increasing with my Y's over the rate I'm increasing with my X's. So from here to here, it goes by 2.5. From here to here, we add 5. So I can put 2.5 divided by 5 and find my K value because it's Y over X. So Y over X would then be 2.5 over 5. And I get 0.5 centimeters because that's the height that it's increasing at. So our rate would be 0.5 centimeters, okay? Or what you could do is find the slope of the line, which is the same as our constant. So you could have plugged this into an equation, and you could have had our y minus our y over our x minus our x. And as you see here, we get the exact same setup. Alright, so that is how to do that. There's multiple ways. So there you go. I know this is what we've been doing recently, so I could see why you did that, but related to this lesson, this is how we solved. So there we go. Alright, now here we go. It says, what is the slope of the line here? Alright, so multiple ways we can solve this. First off, you can just look at the line and calculate it. So we know our slope is our vertical over horizontal, or y over x. So we start here, we can choose 2 points and figure out our vertical and horizontal distance. So my horizontal distance is 4 and my vertical is 20. So 20 over 4 would give me 5. Or what you could do is find the coordinates of each point and solve the way we just did in that last problem. So I'm going to have my y minus y over x minus x equals slope. So I'm going to have 60 minus 40. And I'm going to have 4 minus 0. Oops. And I end up with 20 over 4. Once again, identical. And I get the same slope. Now it says, what is the meaning of the slope in this situation? Well, it's talking about Andre's bank account. And so let's see what happens. So each week it's increasing here. And that's how much money. So if we just found our slope, that means for every 1 week, his bank account goes up $5. Okay? So bank account money increases by $5 each week. Alright, so that's that. On to the next So it says, make a sketch of a linear relationship with the slope of 3 that's not proportional. So that should be a flag, oops, sorry. That should be a flag that it's not going through the origin, okay? So, let's go ahead and do this. So we can pick any point on the y-axis to start our line. Let's start at 2, I guess, okay? And so already we know this isn't going to be proportional because it's not going to come out of the origin. So we're starting here. Now, our slope is 3. So that means I have to have a vertical increase of 3 and a horizontal increase of 1. So it's a little hard to see here, but we can go to the right 1 and up 1, 2, 3. So it's going to be around there. We can go ahead and do that again. So 1 to the right, 1, 2, 3, up. So that would be our line there. Okay, so yours should look somewhat similar to that. Okay, now it says show how you know that the slope is 3. Well, we know it's 3 because we just, it's our vertical over horizontal, which then equals 3 over 1. Okay, and our graph represents that. Now it says to write an equation for the line. So we're going to use y equals mx plus b. And if we do that, this is our y-intercept, and m represents the slope. So our slope is 3, and then our y-intercept, so where our line hits the y-axis or starts, is at 2, a positive 2. So that would be this equation of our line. Alright, last one here. So it says, describe how the graph of y equals 2x is the same and different of the graph that has y equals 2x minus 7. So same, and then let's do different. Okay? Alright, so if we look here, that 2 represents the slope in both of those. So they have the same slope. Alright, now if we were to graph these lines, I'm going to do this pretty rough, okay? So it's saying for every 1, 2, go over 1. Here's one of my lines. Starts at the origin, and I'm going to increase by about 2 over 1. Now if I start at -7, let's say that's right here, and I'm going to increase at the same rate. Okay, not too bad. Now, those lines are then parallel. Okay, so since they have the same slope, they will be parallel. Okay? Now, some things that they're different is they're at different locations on the graph. Okay, and they don't go through any of the same points. So since they're parallel, they'll never go through the same points. There we go. So you could probably think of a few more to add there, but that is what I came up with. Alright, that is it.